start the record. Let me minimize this. And now I can bring up my ink and write. Go ahead.
Okay, so it says add and subtract complex numbers.
Okay.
So the equation says, in parentheses, negative 14 plus 3i. And then minus parentheses 14i. And it says to express the answer in the form a plus bi.
Okay. These are actually pretty simple. You add the real parts. This is real. This is imaginary. What's 14i? Real or imaginary? Is 14i real or imaginary?
Imaginary.
Okay. Now operate on the reals. The real part on the right side is actually 0. In other words, a is 0 on this 14i. So add the real parts, or not add, but subtract. What is minus 14 minus 0?
Minus 14.
Okay. And then subtract the imaginary parts.
Subtract, negative 11.
Negative 11i. And that is of the form that is in. In other words, you wouldn't want an answer like this. If I gave you an answer like that, that is not in that form. I would need to change it to 2/4 plus 3/4 I. Then I'd make that 1/2. So now I would have it in a plus bi form. So that's what they mean when they say stick it in a plus bi. Okay?
Yeah.
What else? Adding, subtracting, and multiplying are extremely easy. The only one at all that has any difficulty to it is dividing. But let's go over each one of them just to make sure you know how to do it. We just did a subtraction. An addition is even easier. Then you just add the real parts and you add the imaginary parts.
Yeah, it's an addition one next.
Okay, what's that?
It's parentheses 4 plus 14 out of the parentheses.
Hold on. Like that?
14 in the parentheses. A different set.
14i or is it 14?
Parentheses 4 close parentheses plus parentheses 14 minus 4i close parentheses.
Okay. So the answer is? You're just doing two separate processes. You're going to add the reals and you're going to add the imaginaries. So what's the real?
The 4 and the 14.
Add them together. What's that answer?
18.
And what's the imaginary?
4i. Negative 4i.
Negative 4i. Very important. Don't drop negative signs. It's one thing that, hold on a second, let me close my door. It's one thing algebra students are extremely prone to want to do, which is to drop negative signs. You can't. You'll get the problem wrong. They're as important as a number or anything else. Okay. And again, this is in A plus BI, where A is 18, B is what?
4i.
Actually, B is negative 4. B is a real
Right,
number, and it's the coefficient of the I. Well, in this case, the coefficient is -4.
Okay.
Okay? Does not include the I. In other words, notice it's A plus B times I. All right, what else you got?
Just give me 1 sec here.
Multiplication is pretty easy. You're just going to FOIL. Well, let's do one, because there is one trick you have to know.
Okay.
See if you find a 2-term by 2-term.
A 2-term by 2-term?
A 2-term multiplied by another 2-term. In other words, an A plus BI times an A plus BI. So far, both your problems, one of the terms is missing. It's got 0 for an A or a B.
Okay, I'll make one up. Like,
All right.
6 plus 13i times 4 minus 12i.
Little number. About 10.
Oh, little number?
Yeah, I'm
Okay,
trying to make the arithmetic a little easier.
Okay.
I didn't want to have to multiply 13 times 12. We want to do all of these, doing this math in our head. You don't want to have to use a calculator to do this. Okay, so you're familiar with the word FOIL?
Yeah.
That's what you want to do. Is FOIL these. In other words, you are multiplying a binomial by a binomial. Okay, so use exactly the same technique. FOIL it. What do you get?
Could we go over how to do the FOIL again?
This means first. This means outside. This means inside. This means last. Okay? The first is those two numbers together. So 24. The outside are the two outside numbers together. What's that?
23i.
Now you're multiplying 6 times minus 10i.
Oh, 60i.
Don't drop the negative sign. If there's a negative sign there, you got to say it.
Right, negative 60i.
Because when you say 60i, I'm going to put a positive sign there. Because if you don't give a sign, one is to assume it's positive. So don't drop negative signs. Okay, so that is the first term. That is the outside term. What's the inside term? With sign.
13 and 4.
13 times 4.
Yeah.
So that's plus 42i, right? And I need to write the plus here because I'm writing this as part of a polynomial. In other words, the only plus I can assume is the one in front of 24. Anything else, I got to write it in there. I can't just get that plus off. This whole thing wouldn't make any sense. And then finally, what's the last term? That's the I of FOIL. And what's L?
13 times 10? Negative 10?
Correct. 13 times negative 10, which is what? Minus 130 I squared. So, as with most multiplication problems, you're always going to combine those two, the two inside terms. So, what does that give you?
102.
No, it's a negative 60 added to a positive 42.
Negative, right.
Negative 18i. In other words, I got negative 60i, I'm adding 42i. Okay?
Mhm.
Now, this last term here, let me write it like this, first of all. I squared is equal to what? If I equals the square root of -1, always want to remember that. What's I squared?
Square root of -1.
Got to square it.
Oh,
What's square root of -1 times square root of -1? Are you hearing that whine or whistle in the background?
that might be me. I'm not sure how to fix it, though. Maybe if I like
As long as it's not my new broadband. If it's my new broadband, I'm in trouble. I got to go back to Comcast. I wouldn't be able to do the sessions if I always had that noise in the background. So what is square root of x times square root of x? What's the square root of 7 times the square root of 7? Jameson?
Okay. I think I lost you there for a second.
Okay. What's square root of 7 times square root of 7?
Square root of 7.
The square root of anything times the square root of that same thing is whatever that thing is.
So 7.
Yeah. So square root of x times square root of x is x.
Mm-hmm.
Square root of -1 times square root of -1 is what?
Oh, -1.
Okay. That's what you need to remember. Or that I squared converts to a real number. It's no longer an imaginary number. In other words, I squared is -1. So I can plug that in. So I've got 24 minus 18i minus 130 times -1. Well, that becomes plus 130. Add it to the 24, I get 154 minus 18i, which is in A plus BI format. And that's always the trick when you're working with imaginary numbers, is to convert all of your I squares into -1.
Okay.
And that's all you're going to ever be faced with. There's a lot of I squares and i's. They're not going to give you very many I cubes. But I cubes would be -I. In other words, if I squared is -1, then I cubed is I squared times I, so it'd be -I. But in general, it's the I squared you're going to have to convert. Every time you run into one of them, you need to convert it to a -1. Okay?
All right.
All right. And you want me to make up one for division? Or do you have one?
Can we do another subtraction one real quick?
Sure. Go ahead.
Parentheses 12, close parentheses. Minus parentheses 23 plus 13i, close parentheses.
Okay. That's the answer. Think of this, the part that's confusing you here, and this is why I don't like these problems, because they merely confuse. What this really is 0i. Now you have a real and an imaginary with both of them. So subtract the reals. What do you get?
11.
No. 12 minus 23.
Oh. -11.
And now subtract the imaginaries.
13i. Plus 13i.
Nope.
No?
Nope. We got 0 minus 13. What is 0 minus 13? That's all you're doing.
Oh, negative 13.
Negative 13i.
I.
So there's your answer.
Okay.
Okay? There's no reason for them to try to confuse you here like this, where they leave off part of it.
Mm-hmm.
And yet every problem they've given you has done that.
Yeah, Khan Academy seems to.
Well, I'm never going to criticize Khan Academy, but it's just you maybe have started at the beginning where they haven't gotten to 2 terms, minus 2 terms. I don't know. Could be just a question of that.
Yeah.
Or you're at the hard part. In other words, usually most of my students start off with 2 terms plus or minus 2 terms. And then when they run into a problem that only has a real or an imaginary part to it, they don't know what to do. So
Yeah.
I would say that these are harder than normal ones. And that's why I don't like starting off with them. In other words, if I was going to start you off with a problem, I'd start you off with 2 terms there and 2 terms there. Go ahead and do that.
Okay. Foil.
Nope, we're not multiplying. Foil is.
Oh, yeah, so multiplying. Okay.
When you're adding or subtracting, it's just a piece of cake. You subtract those 2 terms and you subtract those 2 terms.
Okay, right. So negative 7 minus negative 1.
Nope. What is minus 3 minus 4?
Oh,
Now notice this minus sign has to be applied to both of these terms.
right.
In other words, it's 2 minus 9 and it's minus 3i minus a positive 4i. Or minus 3i minus 4i.
So just 1, right?
No. Minus 7. All right. I want to do something, Jameson. Just you cannot do math unless you can do this. You just can't do it. You cannot get away with using a calculator for everything. Single digit stuff you've got to be able to do in your head. Now, here's the best website I have found. It's going to randomly put up problems. I want you to give me the answer as quickly as you can, and I'm going to write it down.
Okay.
Type it in.
Negative 7 minus negative 8. So negative minus a negative is a positive, right?
Okay, here's what I want you to do. This is the first trick. Most important one. These problems give people, they make them crazy because there's so many negative signs. They don't know what to do. Okay? That is a negative sign. That is a negative sign. That is a subtraction sign.
Right.
Okay? So I want you to take all your subtraction problems and turn them into addition problems. And the way we do that is we just go ahead and change it to an addition, but I can't just arbitrarily do that. I got to change the sign on what was being subtracted. It was a negative 8. Now I had to change the sign because I turned it into an addition problem. So now the problem becomes this. Which is what?
1.
Once you get that rule down, most of these become fairly, they're not that hard. It's not that hard memorizing these answers. And that's what I want you to do is memorize. The last thing in the world I would ever want to hear or see is have you do it on your fingers.
Yeah.
That is a recipe for failure. You've got to get by that. In other words, you've got to memorize what. So what's this? Change the subtraction sign to an addition sign.
So 11 plus 9.
Correct. It's that simple. Okay. Now, when you have a subtraction problem like this is not hard. You know how to do these. In other words, when you have a bigger positive number minus a smaller positive number, it's a normal subtraction sign. Don't worry about changing it to an addition problem. It'll still work. You could still make it 10 plus a negative 8, but you don't need to. It's easier done as a subtraction problem. What is it?
2.
Okay. Here, I want to copy this, and I'm going to put it in the chat window, and I want you to click on it. Hold on. There, do you see it? In the GoToMeeting chat window?
Yeah.
Might have to
I don't see it yet, I don't think.
click on the word chat. Now, does it open it up yet?
Yeah.
Okay, now click on that link.
I'm not seeing a link here.
Not seeing a link. There it is.
Oh, no. There it is.
I hadn't put it into the chat. I thought I had, but I hadn't.
Yeah.
So click on that link. Should open up in your browser on your end.
Yeah.
And save it so you can get back to it.
Okay.
Okay? Now, there's no point in you paying me $32 an hour to drill on this program. So the only reason I use this is to tell whether somebody needs to work on it or not. And you definitely need to work on it. You're never going to be able to get past algebra, geometry, trig, pre-calc, all of those things without being able to do single-digit arithmetic, which is what we're asking. We're asking you to be able to add, subtract, multiply, and divide single-digit numbers. Okay, so let's just do a little bit more on this. Hold on, let me get that out of the way. We know this is 4. Go ahead. Now, on multiplication and division problems, I want you to give me the sign first without even thinking about the number.
The sign?
The sign. Is our answer going to be positive or negative?
A positive.
Correct. Okay, good. So we got that out of the way. Now what's the number?
What's the answer?
What's 4 times 11?
Oh, 4 times 11 is 44.
Okay, so it's positive 44. So it's positive, I don't need to write it. I just need to write 44. Okay, give me the sign first.
Positive.
What's the number?
48.
Okay. Again, sign first.
Negative.
Okay. Whenever you have just one negative sign, the other one's a positive, the answer is always going to be a negative, whether it's multiplication or division. Okay, so it's negative what?
55.
Okay. This one?
Positive.
Positive what?
Positive 13.
Okay. Again?
8.
Again?
12.
Again?
2.
Again? Sign first?
Negative.
Oh, you got 2 negatives. When you're multiplying or dividing, when you have 2 negatives, it's a positive.
Right.
Always a negative if there's only one negative. I'm talking about negative signs, not subtraction. Okay? The rules are totally different when you're adding and subtracting. Depends on the size of the numbers. But when you're multiplying and dividing, the signs immediately wash out. That's the first thing you want to think, is what is the sign? You don't want to do the number first and then do the sign second. It's just not a good way to do it. You just always want to do the sign first, okay? So the sign is positive. What's the number?
The 24.
Okay. Now, if you were to spend 5 minutes on this a night on your own, and treating it like a video game where you're really trying to get good. First of all, this is going to scare you. It does not do any good to get 90% good on these. And here's the reason. Let's say you had 90% accuracy. That's enough to get an A in a math class. But that will flunk you on this test here. And the reason is that if you're only 90% accurate, you're going to start using your calculator because you're not going to trust yourself. The moment you go to the calculator, your memory is going to lose these things you've memorized. So there's a very fine line here. If you get 99% accurate, then you'll trust yourself and you'll just use your answer here. But you got to get 99% accurate. In other words, this is a video game where you have to play it almost perfectly. Okay. Otherwise, it won't do any good to memorize these because you'll end up going back to the calculator and then you'll lose your memory of these numbers. Now, they've been throwing a lot of two-digit by one-digit numbers at us. I'm not that. I don't care if you know what 11 times 12 is. I really don't. But
with the,
know what 9 times 8 is.
I went into a new con thing, and now it's giving me multiplying with 2 digits.
Okay, we'll go back to that. Let's answer this. And let me close this page out and get my writing tablet back here. Hold on. All right. Go ahead.
All right. This one is parentheses 1 plus I, close parentheses, times parentheses 3 minus 5I, close parentheses.
Okay. Foil it. First, outside, inside, last.
Yeah. So 1 times 3 first. Right?
Answer. Don't tell me 2 times 4. Give me 8. 1 times 3 is 3. That's the first. Yeah. Okay. What's the outside?
5I.
Minus 5I. You are multiplying that times that, and that thing includes both of those terms, the sign and the imaginary part. So it's minus 5I. Okay? What's the inside?
Multiplying with just variables.
You're doing this part here. What's 3 times I?
3I.
All right? You need the sign. It's plus 3I. You can't ignore that plus sign there. This whole expression won't make any sense. Okay? Now what's the final one? In other words, what's the last?
Is it negative 6I?
No. It's 1I times minus 5I. That's minus 5I squared.
Oh, yeah, okay. That makes sense.
Same thing as 1 times minus 5 is minus 5. And then the I times the I is I squared. So that's the way you do those. It's just like if I had 2x times 3x squared. Well, I'm multiplying the numbers to get 6, and the x times the x squared is x cubed. Okay? Now, we're not done. We're never done with the first step in foiling, because we know we can always combine those 2 middle terms, and with imaginary numbers, we can always substitute something for I squared, which will cause it to be a real number, not an imaginary one. Okay, so let's do one step at a time. Combine the 2 middle terms. This is why the arithmetic is so important. There are no math problems terms that exist that you don't have to do 6 to 8 little steps of single-digit arithmetic. That's the foundation of all math. You got to get good at that.
Yeah.
So it's minus 5i plus 3i.
Would it be a good strategy to take out the i's and then just do the problem
just
normal?
work with the coefficients. Sure.
Okay.
Minus 5 plus 3.
-2.
Okay. And then we'll add the I back in. Don't forget to leave out, or don't forget to add it back in. You know, when I'm adding i's, it's not I squared. That's only when I'm multiplying i's.
Okay.
Okay, and then what's this last term? What's I squared equal to?
What's I squared equal to? Oh, well, -1.
Okay. Now, simplify that. Notice that that has turned real. We lost the I. So we're going to now combine that number with that real part of the number to give me my answer.
Okay.
So what is the real part?
15 parentheses -1 for one thing, right?
No?
Or -15.
Here's what we got. Here's what we got. Minus 5 times minus 1, two minuses multiplied together turns it plus. So that's what we got. Now, finish simplifying that.
Finish simplifying it.
Yeah. Is there any parts you can combine? Do we have any?
The 3 and the 5.
Okay. Do it.
8.
And it goes in front because they want the answer in A plus BI format. So the real number is there. That's a real number also. B is. It's just the coefficient of the imaginary part of that number. Okay?
Okay.
Let's cover at least one division problem, because they're a little different. I can pick one up if you want.
Sure.
That looks like a division problem. It really is not. What it is in the same sense, let me just talk about this for a moment. If I have this, okay, that looks like a division problem, but it isn't. What it is I have to rationalize the bottom. And the way I rationalize it is multiply the top. I can multiply this fraction by the number 1. That's the number 1. And when I apply it, I end up getting root 2 over the top, 2 in the bottom. So it wasn't really a division problem. I didn't do any dividing, because all I did was multiply. Imaginary numbers are the same way. We're not really going to divide. What we're going to do is make the bottom real. We do not want a denominator that is either irrational, like square root of 2, or imaginary, like this one. And the way you make it go away is you multiply the top and bottom by the conjugate of the bottom. Conjugate just means the same two terms, different sign in the middle. I multiply the bottom by that, I got to multiply the top. Remember, I can only multiply this fraction by the number 1. Well, there's my number 1. With me?
Yeah, I think so.
Do the bottom first. Foil the bottom.
So
one step at a time. Just don't let anxiety get in the way. In other words, you got 2 terms times 2 terms. You're just going to foil them.
Okay.
So what is it?
So 4 times 3i, right?
No. First term is the first term times the first term. 4 times 4. That's
okay.
what the F means. First terms of both of them, you're multiplying them together. So 16 is our first term.
Yeah.
Now the outside terms.
3i times 3i.
No, that first 3i is not on the outside. That 4 is on the outside. This plus 3i is on the outside. You see why that's outside? What the difference between outside and inside is? In other words, this is the 2 outside terms. This is the 2 inside terms.
Oh, yeah, okay.
Okay, so you got your first term. Then what are your outside terms?
4 times 3i.
What's that?
Um, 12i?
Plus 12i.
Yes.
Again, I got to have the plus sign. Now do the inside terms.
Negative 3i times 4.
Give me the answer.
Okay. Negative 12i.
Okay. And finally, the last term. And by last, I mean the last of that binomial times the last term of that binomial. That's what we mean by L in FOIL. And the only 2 terms that haven't been multiplied together yet.
So that's negative 9i squared, correct?
Yes. Okay. Now, the whole reason we multiply by the conjugate is so that these 2 middle terms always cancel out one another. Notice they do. I got a plus 12i minus 12i.
Yeah.
That's always going to happen. So after a while, you get good at this. You don't even need to do the outside and the inside terms. Just do the front and the last. Because these are always going to take one another out. So what is 16 minus 9i squared? That turns into a real number. No more imaginary part. How do you do it?
So it turns into 16 times, or minus 9 times negative 1.
Okay. Now do that little arithmetic problem. It's a subtraction problem, right?
Yeah.
Okay. So first of all, do this part first. What's that?
Negative 9.
Okay, so it's 16 minus negative 9. Okay, we'll just take it one step at a time. Now, what is 16 minus negative 9 using the rule I told you about subtraction? Change it to an addition problem.
Yeah. So 16 plus negative 9.
No, you can't change that to an addition sign unless you change that sign. Otherwise,
yeah, so 16 plus 9.
16 minus 7 is not the same as 16 plus 7. You can change these subtraction problems to addition problems, but you have to change the sign of what was being subtracted. So if I'm going to make that a plus, then I got to change the sign on the negative 9 and turning it into a positive 9. Now what's 16 plus 9? Whenever you see positives together like this, it means one positive.
So it's 25.
Okay, so that's our denominator. Notice that it turned real. And that was our goal. Now, we still have to do a little work on the numerator. In other words, the whole point of this division, it's not really division. Notice we haven't divided anything yet. The only thing we've been doing is multiplying. The whole point of it was to do the conjugate, was to get rid of the imaginary number in the denominator. Well, we still have to multiply this numerator times this numerator. Go ahead.
All right, so we're foiling again, right?
Correct. Whenever you're multiplying 2 terms times 2 other terms, it's always foiling.
Okay. So first is, sorry, it starts off with 12. And then it's 9i, right? Positive 9i.
See, notice if I don't put the plus sign there, that looks like 129i.
Mm-hmm.
Because it's part of an expression, I have to put the plus sign there. Okay? That's the outside. Yeah. Now do the inside.
8i.
Sign first.
Positive 8i.
And now the last term. Sign first.
Is positive 6i squared.
Which is 6 times what?
6 times negative 1.
Okay. Now, when I see this, immediately I can just make that minus 6 and get rid of this negative 1. So that's the same answer. Now, combine everything that's the same type of term. In other words, if you can combine the real numbers, do it. If you can combine imaginary numbers, do that.
Okay.
Starting with the real. With the real in front. That's the A.
So that's, the equation would be 12 plus negative 6, right?
No, just 12 minus 6. You don't need to put.
Oh, okay.
12 minus 6. So what you're doing is combining that, you're adding it to that, which makes it 12 minus 6.
Oh, okay. So 6.
Okay. Now, combine that term with that term. And when I say combine, I mean add. Combine is just another way of saying add.
Right. That gives us 17i squared. Positive 17i squared.
And it's not I squared. Remember, we're adding. When I add 9i to 8i, I get 17i. Think of I as an apple. If you have 9 apples and you add it to 8 apples, you get 17 apples. Totally different than multiplication. You got to be very, very careful not to mix up when you're multiplying and when you're adding and subtracting. That'll kill you as fast as not knowing the multiplication tables. Okay? Now, so we've combined everything, and underneath this is our denominator, which we got when we multiplied this times this. We got 25. And that's a perfectly good answer. It just isn't in the format that they wanted it in. They wanted in A plus BI format. So I have to split this into two fractions. 6 over 25 plus 17 over 25i. In other words, A is that, B is that.
Okay.
So when you're getting it into A plus BI format, notice that that is not in A plus BI format. That is a fine answer. There's nothing wrong with that. That would pass every math test unless the teacher said, give me your answers in A plus BI format, and then it's got to be 6/25 plus 17/25 I. And then make sure this I is not in the denominator. In other words, there's A, there is B. Actually, there is B, plus 17/25. Okay, and neither one of those can be simplified. You can't simplify 6/25. You can't simplify 17/25. So that's my final answer to this problem.
Okay.
Okay, but the process is always the same. It's never division. It's always multiplying top and bottom by the conjugate of the bottom. Now, let me just make sure you know what conjugate means. Tell me the conjugate of that.
Negative 3x.
Oh, just as the same exact two terms with a different sign in the middle. That's what conjugate means.
Oh, okay.
So no matter what the sign is in the middle or no matter what the terms are, okay, this time tell me the conjugate of this.
Negative x minus 9, or negative 9?
Correct. In other words, it's just real simple.
Mm-hmm.
The only thing you have to change is that. And then, of course, you're going to have to simplify this because I got two negative signs in a row here. So if I turn it into an addition problem, I got to change that and that. So I end up with minus x plus 9 is the conjugate. But the conjugate is merely whatever the two terms are, positive or negative, and whatever the sign is, change it. That's the conjugate.
Mm-hmm.
And when you multiply something by the conjugate, even though I got two terms by two terms, I know what the answer is. It's 9 minus x squared immediately. I don't have to FOIL it because I know the two middle terms are going to cancel one another out without doing the math. So what I really have is the first term, 3 times 3, and I have the last term, minus x times x, which is minus x squared.
Okay.
Okay? All right, so there's a couple other things on imaginary numbers. That pretty much covers imaginary numbers. They usually will give you this little thing here. Let me just do this. I'll bet you've seen this. That's an I. Well, if I squared is minus 1, what is I to the 4th?
Positive 1?
Positive 1. In other words, it's minus 1 times minus 1. And then it repeats. In other words, I to the 5th is just I. Again, square root of minus 1. I to the 6th is the same as I squared. I to the 7th is the same as I cubed. And I to the 8th is the same as I to the 4th. Okay? So you want to learn that pattern, and it repeats as you go up. And here's the problem they're going to give you. What is I to the 24th power?
24th. 1?
Yeah. In other words, what you do is you divide that by 4, and whatever your remainder is, in this case it's 0, so you use that. If it was the 25th power, well, then when I divide 25 by 4, I get a remainder of 1, so I'm using that. Whoops. I'm using I to the 1 power. So I to the 25th is the same as I.
Mm-hmm.
So a harder one. This is the one they'll give you. Okay? Something like that. Well,
502.
divide 502 by 4. Use your calculator if you need to.
Divided by 4, you said?
And what's the remainder? That's what's important, not the number in your calculator. In other words, that's not going to do you a whole lot of good. You really kind of need to do it this way. Okay? Now, first of all, every whole number, 500, 400, 300, 200, are all perfectly divisible by 4. So what's my remainder here? I don't care what this number is. The only thing I care about is the remainder.
So we're square rooting, right?
We're not square rooting, we're dividing, long division.
Oh, okay.
4 goes into 500 evenly. What is the remainder going to be here? if 4 goes into 500 evenly, okay, here. What's this? What's the remainder when I divide 4 into 9?
4 divided by 9?
No, 9 divided by 4.
The remainder.
First of all, how many times can 4 go into 9? Can it go 3?
Twice.
Can it go 3?
I don't think so.
No, 4 times 3 is 12. So what can it go? What's the maximum times 4 can go into 9?
Twice.
Okay, so we put the 2 there, multiply it, subtract, there's your remainder. Remainder of 1.
Okay.
So when I'm dividing 4 into 502, 4 goes into 500 exactly 125 times with a remainder of what? I mean, 4 divided into 502 has a remainder of what?
4 divided into 502.
Yeah. In other words, it's 125, but it doesn't go evenly. 4 times 125 is exactly 500. So what's the remainder going to be?
377.
Hold on. Let's do this correctly. First of all, 4 goes into 5 once. Multiply by 4, subtract, bring down the next thing. 4 goes into 10 twice. Multiply 2 times 4, subtract, bring down the next term. 4 goes into 22 5 times. But then when I multiply it, I get a remainder of 2. Therefore, I to the 502nd power is the same as I squared. It's whatever the remainder is. If the remainder would have been 1, then it would have been I to the first power. If the remainder would have been 3, it would be I cubed. If the remainder would have been 4, then there is no remainder. And it's whatever, it's 1. If there's no remainder, it's always 1. In other words, it's I to the 4th is 1. Now, the secret to dividing by 4 is, obviously that's not divisible by 4, right? It's got a remainder of 2. So it's not evenly divisible by 4. But if I have a number like this, well, I know that that's easily divisible by 4 because I know how it's 12. Okay? No remainder. If you have a multiple size digit, 5, 2, 3, 2, 4. In other words, 52,324. Is that divisible by 4? And the answer is yes. The only thing I have to know is that the last 2 digits are divisible by 4.
Okay.
So if I had I to the 520 to this power, I would know that when I divide that number by 4, I get 0 remainder. Which means it's 1.
Yeah.
I to a number that is a multiple of 4 is the same as I to the 4th, or I to the 8th, or I to the 12th. They're all the number 1. They're all I to the 4th. Okay? And that's about it with imaginary numbers. I can't think of anything else they're going to teach you. Do you have any problems? It's actually 5:30, so it's time to go. But I can't imagine what they would have given you that we didn't cover today.
Yeah.
Jameson, work on that math lab page.
Okay. I'll make sure to do that.
More than anything else, I guarantee it. It'll help you a lot more than my tutoring sessions will help you. Seriously. It will. It'll turn you into a math genius. You just got to get really, really good. You can't just get so-so.
Mhm.
So-so means you're going to use a calculator the rest of your life. If you get really, really good, you will not use a calculator when you go to multiply 7 times 9. You won't need to. You'll know what the answer is, and you'll be 100% sure of it.
Mhm.
All right. Jameson, have a good rest of your week, and I'll talk to you next time.
All right. Thank you.
You're welcome. And to close out Go to Meeting, just click on that X in the upper right-hand corner.
Okay. So payments.
Yeah, I'll send an invoice. Let me make sure. It's 32 an hour. You want me to send it to jamesonpkennedy@gmail.com?
No, I have a different email for you.
Okay. Hold on a second. Let me write it down on a piece of paper. Okay. Go ahead.
So the main contact email is going to be that one that you just said, but the payment email is going to be brentpkennedy@gmail.com.
Okay, BRENT, Brent P. Kennedy?
Yes.
PKENNEDY
Yes.
@gmail. Email's so good, it makes you wonder why anybody uses anything else.
Right.
Truly. Okay, I will send him the invoice, and he can just click. It's a one-click payment method if he goes to the link that's in the invoice that I send him.
Okay.
And like I said, it's 32 an hour now. Actually, it was more expensive last semester, but yeah, no, I decided to drop my prices a little bit. So,
all right.
Okay, Jameson, I will talk to you next time.
Okay. Thank you.
You're welcome. Bye-bye.
Bye.